Our next lesson is on composite functions. A composite function is a function that is the composite of two other functions. So the function f of g of x is called the composition of f with g. And the composition, or excuse me, the function f of g of x is denoted by f o g of x and is defined by using the output of the function g as the input for the function f. So f o g is read not fog, but f operates on g, while f of g of x is read as f of g of x. Well, let's see what this would look like in practice. Imagine that we have f of x equals 2x minus 1 and g of x equals root x. We want to determine f of g of x. Well, before we begin, let's recall that f of x equals 2x minus 1 means f at block equals 2 block minus 1. Now, f of g of x is f of g of x, so this is now the block, right? F at block is 2 block minus 1. Well, our block is now g of x. So, instead of saying 2 block minus 1, we'll say 2 g of x minus 1. What's g at x? Root x. So it becomes 2 root x minus 1, and we can say f of g of x equals 2 root x minus 1. Okay, well, let's try g of f of x. Okay, well, in order to do g of f of x, we should recall that g at x equals root x simply means that g at block equals root block. So if we say g of f of x, we're saying g of f of x, and we're saying that the input for g is f of x. So we're really saying input f of x for that block. So instead of saying root block, we say root f of x. And what is f of x? Well, on the other page we knew that f of x was 2x minus 1. So g of f of x is the square root of 2x minus 1. Okay, well, let's see if we can evaluate a couple here. We learned earlier that f of g of x is 2 root x minus 1. So let's see what f of g at 25 is. F of g at 25 is therefore 2 root 25 minus 1. That's the same as 2 times 5 minus 1, 10 minus 1, which is 9. So f of g of 25 is 9. Okay, well, how about g of f of 25? Is that the same as f of g of 25? Well, let's find out. We see here that g at f of x is the square root of 2x minus 1. We learned that in part D. And recall that if g at f of x is the square root of 2x minus 1, then g at f of block is the square root of 2 block minus 1. We substitute the block in for the x. So g at f of 25 is 2 times 25 minus 1, because 25 is the block. Well, that means it's 50 minus 1 under the square root, which is the same as root 49, which is 7. So g at f of 25 is 7. Now, what conclusions can we draw from those last two questions? Well, since f of g at 25 is 9 and g at f of 25, g at f of 25 is 7, we see that f of g at x does not necessarily equal g at f of x. Okay, let's do another example. We're given the functions f, and we're given these in set notation form. So we've got 4 ordered pairs in the function f, and we're given the function g, and we've got 4 ordered pairs in the function g. Well, we want to know what's f of g of 1. Well, f of g of 1 is the same as f at g of 1. Well, how do you calculate g at 1? Well, that means on the function g, what does y equal when x is 1? Well, in the function g, when x is 1, y is 3. So g at 1 is the same as 3. So f of g at 1 is the same as f at 3. So what does f at 3 equal? Well, we come up to f and ask ourselves, what does y equal when x is 3? But we see that in the function f, x never is 3. So f at 3 doesn't exist, which means f at g at 1 doesn't exist. Okay.